What's up guys, Major Math with another video on fluid mechanics. If you have any questions, drop it in the comments, and if you're having trouble with other problems, I've attached my email in the description, so please feel free to reach out. Without further ado, let's get started. Question 2.7 in the textbook says an open cylindrical vat in a food processing plant contains 500 liters of water at 20 degrees Celsius and atmospheric pressure. If the water is heated to 80 degrees Celsius, what will be the percentage change in its volume? If the vat has a diameter of 2 meters, how much will the water level rise due to this temperature increase? Okay, first step, write down your goal. So our goal is to find the percentage change. Find percentage change in volume due to the temperature increase, and find how much the water will rise. So change in height in water. Right? Okay, so our givens, it's cylindrical. So we know that we're probably going to have to get into volume or the area of a circle or something. Yeah, that it's 500 liters of water. Temperature, the initial temperature is 20 degrees Celsius. And the pressure is just atmospheric pressure because it's open. It's also equals 11325 pascals. The water is then heated at 80 degrees Celsius, so the final temperature 80 degrees Celsius, and the diameter is 2 meters. Okay, so this one's kind of tricky because if you go on this table where I usually go, just look at main equations, looking at what variables are in there. It's not on here, so the equation we're going to want to use. If you go to chapter 2.3, page 37, you'll find something called the bulk modulus of elasticity. And I'm writing down the formula right now. There's two formulas, but the bulk modulus elasticity is just an equation used to determine how resistant a substance or fluid will be to volume change. So you can see how this applies pretty closely. Cursive P is pressure. This is supposed to be rho, but it looks like a P. This is density, just so you guys understand. So there's two equations for it. We're using this because our pressure is constant, so these will cancel out once we equal these each other. But if you see these, we have volume in here, and we're going to be able to find density, and the pressures will cancel out once we send them equal to each other. So really we can solve for volume and get that change of volume. I'm going to put initial volume here, but you guys will see what I'm talking about in a second. So this is both equal to the bulk modulus of elasticity, so we can actually make these equal to each other, right? So change in pressure, change in volume over volume, and this is initial. Yep. Initial, not that. And these are equal to each other. Oh, psyching myself out. Okay. These are equal to each other. If we divide by change in pressure on each side, and just get rid of those, and turn into 1, they'll turn into 1. And then we can do it where we rearrange it and put volume initial, or change of volume. Let's put change of volume. Don't forget the negative sign, change of volume over the volume initial equals the change in density over. Alright, if you do some algebra, you can get here. Okay, so how does this help us? We have the initial density, we have the initial volume. We don't have the initial density, but we can find the initial density. Change in volume and change in density. What we're trying to solve for here is the final volume, right? So we're trying to find, it says find the percentage and change in volume, right? So to do that, we're going to have to find the final volume, and we already have the initial volume, and if we find that final volume, then we can divide the final volume by the initial volume to get that percentage we need. So we can figure out density, and then that way we can solve for final volume. So we can rewrite this, right? Because change just means this is what change means, right? Final minus initial. That's all that means. So we're trying to solve for a final volume. So let's go ahead and rearrange this once more to get final volume all by itself. Okay, there we go. So this density we can get from the textbook because we have the degrees. We have the initial volume. Now we can just go ahead and plug in everything we know. So looking at the textbook, we know that water, I can show you guys what I'm looking at here. So it says physical properties of water. So we're at 20 degrees for initial, it gives us the density. And then at 80 degrees, it gives us the density here too. So we have water density at temperature equals 20 degrees Celsius. This will equal 998, and this will equal 972 kilograms per. Okay, so we have our densities, we have everything we need to solve for this final volume. So we got 500 liters. Okay. So all these units will cancel out, and once we put it in the calculator, it will be 513 liters. So the volume will increase. Okay, so now that we have the final volume, we have to find the percentage. So all we do the percentage is just the final volume over the initial volume. So 513 over 500. And that will give us a percentage. Well, that will give us a number of this. And then to translate that to percentage, that will be 102.6%. Alright, so that's our percentage change. It increased by, well, you could say if you multiply this by 500 liters, you'll get 513 liters. Or you can say it increased by 2.6%. Either way works. And then we have to find the change in height, right? So we got to think about the change in height. So where do we get that from? So we know the volume of a cylinder, right? Cylinder is pi over 4 diameter squared times the height. So we know that, right? So we're gonna have to find what the height. To find that change in height, we're gonna have to find the initial height, and then we're gonna have to find the final height. So we gotta use this formula 2 times. So we know that the volume, the initial volume was 500 liters. Let's go ahead and rearrange this first before I do this. Right. Okay. So we need to find the initial height and the final height to find the change in height. So we know all these numbers, so let's go ahead and plug these in for the, we'll do initial first. So initial height, that will be 4 over pi times the initial volume, 500 liters, over a diameter that was given 2 meters squared equals the initial height. And that number will end up being 0. Well, before we do that, I'm going to show you a unit conversion. We gotta convert the liters. So we know that 1,000 liters is 1. Yeah. That will help us with the units. So and this will end up being 0.163 meters. So that's the initial height. So now we gotta do the final height. So we got the same formula. The final volume is 513 liters. Do the same unit conversion. Get this from the textbook. 1 cubic meter is equivalent to 1,000 liters. Then we got the same diameter, and that will equal 0.159 meters. So find change in height. Change in height equals final minus initial. So change in height would equal I did these backwards. I looked at my notes wrong. I got these backwards. There we go. And that will give us a change in height of 0.004 meters. Holy shit. Thanks for watching, soldiers. Don't forget to leave a like and subscribe for more content like this. If you have any questions, leave it on the comments, and if you need help with any other problems, feel free to contact me with the email shown on the screen.